Welcome to the Explainer. In these explainers, we take, well, complex topics and we try to break them down so they're super clear and easy to get.
So today we're going to dive into a really core concept from computer science. You see it right there in a typical syllabus. It's all about how computers make sense of the math that, we just type in.
Okay, so when you or I see an expression like this one, a plus b times c, our brains just, boom, they know to do the multiplication first, right? It's just second nature for us. But for a computer, well, that's where things get a little more interesting.
You see, for a computer, that's actually kind of ambiguous. Does it go left to right and add first, or does it multiply? Without a really strict step-by-step process, it could get the answer completely wrong. So let's dig into how machines actually figure this out. And that right there, that's the central problem. The way we write math, with the operator in between the numbers, that's called infix notation. Works great for our human brains, but for a machine that just wants to follow a simple one thing after another process, not so much. So the solution is to translate our human-friendly infix into something that's way more computer-friendly, called Postfix. And you'll notice right away, in Postfix, the operators come after the numbers. Yeah, it looks a little weird to us for sure, but for a computer, this totally gets rid of all the guesswork. Okay, so to make this translation happen, our algorithm needs a couple of essential tools. You can kind of think of it like, a mechanics toolkit, but for mathematical expressions.
So, the most important tool in our kit is this thing called a stack. And it's a data structure that works on a really simple but powerful principle. Last in, first out. Or LIFO, as you'll hear it called. The analogy is perfect. It's just like a stack of plates. The last plate you put on is going to be the first one you take off.
And a stack has two main jobs, really. You push something onto the top and you pop something off the top. That's it. It's simple, I know, but it's going to be incredibly powerful for what we're about to do.
All right, next up, we need a rule book. This is called operator precedence. You probably know it from school as PEMDAS or BODMAS, right? It's just a simple hierarchy. Multiplication and division, they have higher precedence. That just means we deal with them before we deal with addition and subtraction. But what happens if the operators have the same level of importance? Like, say, a minus b plus c. Well, that's where this idea of associativity comes into play. For the kind of math we're doing here, we just work from left to right. Simple as that. It's another one of those rules that just prevents any kind of confusion.
Okay, so we've got our stack, we've got our rules. Let's actually put them to work. We're going to walk through the conversion of that original expression, a plus b times c, step by step. Let's do this. All right, so here's our setup. On the left, we've got our input that we're going to scan through. In the middle, that's our operator stack, which is empty right now. And on the right, that's where we're going to build our final output string. We're just going to go character by character from left to right.
First up, we scan the a. It's an operand, a number, or a variable. So boom, it goes straight over to the output string.
Next, we hit an operator, the plus sign. We look at our stack, it's empty. So we just push the plus sign right on there. It's just going to hang out there for a bit.
Okay, next up is b, another operand. So just like a, it goes right to our output.
Now pay attention, because this is a key moment. We see the multiplication symbol. So we take a peek at what's on top of our stack, and it's a plus sign. Now remember our rules? Multiplication has higher precedence than addition. So that means we can just push the star right on top of the plus. No problem.
And finally, we scan our last operand, c. And you guessed it, it goes straight to the output string.
So we've hit the end of our input string. Now what? Well, now we just empty out the stack. And remember that LIFO rule? Last in, first out? That means the star comes off first, then the plus. And look at that. There it is, our final postfix expression. A, B, C, star plus. Okay, I know. That might feel like a lot of steps, a lot of pushing and popping. So you might be asking, why go through all this trouble? Why is this conversion from infix to postfix so incredibly important in computer science?
Well, the answer is, it's all about efficiency. This final string we made, it is completely 100% unambiguous. And that allows a computer to figure out the answer using a process that is just, well, stunningly simple.
I mean, just look at how easy this is for a machine to process. It just scans left to right. Does it see a number? Okay,
push it onto a new stack. Sees another number? Push it. Sees an operator? Okay, pop the last two numbers, do the math, and push the result back onto the stack. It just keeps doing that until there's nothing left. The final answer is the only thing left on the stack. It's just pure, simple efficiency.
And listen, this is not just some abstract theoretical exercise you do in a classroom. This concept, the one we pulled right from that syllabus, this is the actual engine that powers so much of our world. It's in the compilers that turn our programming code into working apps, it's inside the scientific calculators on our desks, and it's even running in the query engines of massive, complex databases.
It's one of those hidden but absolutely essential pieces of logic that just makes our digital world work. Which, it really makes you wonder, doesn't it? What other elegant, kind of invisible algorithms like this are running right now, all around us, translating what we want into a language that machines can actually understand?